Okay, and in case I forget to, because this recording does not start automatically. Okay, so yeah. All right, so where were we? We were, I think, on the pig giants. We talked about these questions, and we actually talked about these also. This also we covered, and yeah, these things we had covered. All right, so in the previous session, we covered the joins in Pig Latin, and so you must have noticed that Pig Latin is nothing but a very simplified SQL. So Pig Latin is, instead of a single big query, a full query is broken down into statements, and those statements simplify our life. All right. So again, so there is something called limit and sample. So when we want to see only first 10 records, we say limit. All right. And in case, so we say limit. Uh, so let's say we loaded records into divs and we only want to see first 10 records. So we say first 10 equals limit divs 10. First 10 is just another variable. And then we dump. The moment we dump, only then the whole process of loading the data, figuring out first 10 records, all of this process starts only if we say dump or we say store. All right. Till then, it's like declarations. We are declaring that divs is equals to load of NYSE dividend and first 10 is equals to limit divs 10. So that's true for the whole of Pig Latin. Then everything is a declaration until you say dump or until you say store. All right. Now sample is something which is important when it comes to the big data. So whenever you are doing execution, it makes sense to basically pick a random sample. Whenever you are testing your algorithm, testing your strategy, always use sample instead of just picking the first 10 records or last 10 records. Good. So the way you do it is say sample. Sample is the keyword. Divs is your name of the dataset and a name of the dataset, or we also call it the name of relation. And then we say sample divs, and then we say percentage. I mean the ratio. Okay, something between 0 to 1. 1 means 100%, 0 means no records, and it gives approximately those many records. All right. It gives approximately those many records. So if you have 110 records and you say give me 10%, so you can get either 10 records or you can get 11 records. Or if you have say 115 records, if you say 115 records and you say give me give me approximately a sample of 10%, so you might get 10, 11 or 12. All right. So it's an approximate sample. It's not identical sample, because if it tries to make it very precise that it is going to give you exactly 10% of records, there are high chances that the records are not really randomly selected. Sample gives you randomly selected 10% records, or whatever ratio you want. Okay. Now here is the question for all of you. Yeah, let me explain, Tarak, the sample again. Let's say there's a huge data set and you want only a small fraction of the total data set. Now there could be two ways. One is you just pick first few, middle few, or last few records. Or you could say that give me randomly, properly randomly, 10% of the records. Okay. So selection of these 10% record might take long time, but rest of the process, which depends on this data set, will be fairly small, faster. And hence, this is a good technique to test your algorithm. Okay, because when we deal with big data, lot of data is generally heavily skewed. Reason being, and this data, when we say sample 10%, or say we are picking first 100 record out of billions of record, and then we are just testing our algorithm against these first 10 100 record. So your algorithm might deceive you at this point, your testing might deceive you. Your algorithm might run really well for first 10 records, but for rest of the data it might give really wrong results. So whenever you're testing your algorithm, or testing your query, or testing your strategy, always make sure that you run it on a sample of data instead of a fixed set of input. All right. And the we are saying here in this state, saying give me sample of divs, a 10% sample. Point one is 10%, a ratio. Okay. One means 100%, point 0.5 means 50%, and so 1 means 100%, 0 means no records, and point 0.5 means 50%. Correct. That's a better way to say it. Thank you, Vikas. Will sample help me creating a training set and test set as we split? Oh no, I read it wrong. No. So whenever you are creating a training data, you keep the training data to the maximum. You do not pick up a small subset of training data and then you test. No. The way most of the training happens is you train your models on the whole data and test your model against the some record. So generally we because the more number of records are there in training is, you can all of you, before it goes all of you go out of the discussion, let me just take a little digression. Okay, let me just digress a little. So whenever we train, what does it mean? So most of the big data problems or machine learning problems rely on that, given the past history of data, can we make predictions? Okay, can we make predictions? Now the easiest way for you to visualize this is, given 10 records, 10 points, can we predict the 11th point? Point is a two-dimensional plot. So, what do we mean to say is, can we plot a graph which we can extend to the future and predict something? Okay, can we draw a line, can we draw a curve such that fits my past data properly, and based on that we can do the prediction. Okay, so most of the machine learning is about sort of preparing a correlation in the past data and doing the future predictions. Okay, and preparing this correlation in the past data, this data set is called training data set, on which we are trying to figure out what is the plot, what is the graph, how does this look like on the map. So this is called training data set. We are training our model. Model may be as simple as a graph plot. Model may be as complex as your neural network. So training means training data means the data which we know for which we know the output. Okay. So if it's a single variable, we say that for x, y is this much, for x2, y2 is this much, and so on. So this is training data. Now, Now, whenever you are training your model, you do not take a sample and train it. You basically take the full sample and train your records. And in those cases, the you test against, uh, you know, the other reason is that you generally pick up the way the percentage or the sample might come into play is, I mean, sample will not be a good fit in this. What I'm trying to explain. So generally, what you do is, if you have got a great history, so what you do is you first pick 80% of the records, figure out a relationship between input and output, and then whatever relationship you have figured out, you compare it against remaining 20%. I'm saying remaining. All right. So generally the data is split into timeline. So if it's like saying that if somebody comes around and says that, hey, I can predict your future. So first, to make sure if that person is telling the truth, we tell him, we ask him about our past. If he can tell, then that guy is able to predict our future. All right. So in the same way, when you prepare a model, we test against a certain past data. So you have got past 1,000 days data. So from 0 day to 750 day, you train your model. From 750 day to 1000 day, you basically test the trained model whether it's giving us great result or not. Okay. So generally, whenever we are training and doing this, we do not randomize it. We generally take it on the basis of timeline or any other progression. All right. So, was I able to justify my answer, Vikash? But it's a very good question, I must say. All right. So, was everybody able to correlate on what are the things I was talking about? Yeah. Abhishek, Malvika and Amar, Harshal, Minu, Nitika, Pop, Rania, Sanjay, Sweta, and Vikas. All right. So yeah, good, good, good. If you got that idea about training data set and testing it, then I mean, it's great. All right. Although it's not a very complex topic, it's just the meaning of the words, the taxonomy that matters. All right. Now here is the question for you, all of you. So imagine that we are loading a file.tsv, tsv as in tab separated, and div equals load that file, then sum equals sample divs point one, and dump sum. Now question to all of you is, we said dump twice. Okay, we are trying to dump the data in sum twice. Now the output in these two executions will be same or different. Will the output of first dump and second dump will be same or different? Anyone? All right. Tarak says should be different. Vikas says may or may not be. Okay. 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 Great. Great. So yeah. So answer may not be. I think I would change my answer, and I like Vikas's answer. May or may not be. Okay. Most likely no. Okay. I think this is more political correct answer. Meaning, I mean to say that probability of the two outputs is being same is very, very low. Okay, let me close the Chrome and also close, yeah, good. So Vika, Goel is asking that first I wish to know why we dump twice. Okay, so I this is not generally required. We just dump twice because I wanted to see whether you understand the difference between declaration and execution. All right. So so all I mean to say is correct. Yes. So Tarak, when yeah, correct. So although here if you say that we said divs equals load and that sum equals sample, when we say dump, it is going to execute sample and load. And again we say dump, it is going to again execute sample and load. Alright? Every time we say dump sum, it is going to do all the chain reaction. The whole chain reaction will happen. For dumping sum, it requires sample, and for running the sample, it requires divs, and for running divs, it requires load. Correct. Correct. Correct, Nitika. Because execution starts at dump or store. If we had said store sum, the two file would have been different. Now, Tarak's question is, what happens if sum equals sample is called after first after first dump? Okay, then also it is going to be different. So it calls second and third line, but first dump only first and second. So it calls first, second, and third line, okay? But first dump only first and second. No. So whenever we say dump, okay, so it will execute sample and load. Then we say again second dump, it is going to again execute sample and load. And again, if you have something else, okay, so it's like the Apache Ant, the moment you say make, it is going to run all the things on which make depends. Okay, it's more likely when I say load something, sample something, it means that some depends on sample, depends on some depends on divs depends on file.tsv. Okay, so is it clear, Tarak? No? Mm-hmm. All right. So let's say, and what kind of sample will it be? Let's say, let me just copy this, that will be better. Okay, I'll show you. Okay, now let's have a look at it. Okay, so let's say there is some other sentence y equals sample divs point 2. Okay, and then we have you know, now if this execution, the line number 3, which is dump sum, will execute these two. Okay, first it will try to execute this one and then it will execute this one. So basically dump sum will execute these two statements. Similarly, again dump sum, we say it is going to execute these two. Why? Because for sum we require sample, and for sample we require divs. Okay, and therefore divs will get executed first, and then whatever data comes in, and then that goes sample, and then we get the result. All right. This will not get executed. Okay, this will get executed if we say dump y. In that case, if we say dump y, first this will get executed, and then only this one, and that's all. Basically this will execute 1 comma, this is line number 1 comma 4. Okay, so if you say here sum, correct, like this, so then what will happen is, okay, what will happen is it will execute line number 4 and line number 1. All right, and this will execute line number 2 and line number 1. Sorry, not in that order, but yeah, it will be like 1 comma 2 in that order, and 1 comma 4. All right, everybody clear? Awesome. Yeah, great. Now, as we talked about pig, the basic philosophy, one of the pillars in the philosophy was that pig fly, meaning most of the pig is about making it really, really fast, making the execution really, really fast. So, all right. So the first thing which pig provides you for parallelism is the keyword called parallel. The parallel keyword essentially controls how you are going to, it essentially controls how many reducers are going to be there. Okay, so you say group by, say for example when we are saying group by daily and say parallel 10, meaning for grouping you can use 10 reducers. Like in MapReduce we read, when we are executing our reducers, we can tell that these many reducers is what we are looking for. All right. Okay. So this parallel syntax will only make sense when there are reducer code involved. If there is no reducer, then there is no point of having the keyword called parallel. Okay. So either we can either we can mention it along with every statement saying parallel 10, or we can set it as a variable in the script. Set default parallel equals 10. You can see this. So here, okay, so this is like forcing pig to execute that many reducers. All right, by default for every input file, say you are churning a data which is close to, which is having 100 gigabyte size. In those cases it will create one reducer per gigabyte, and hence it is going to create 100 reducers. Okay, now if you look at it closely, then you will realize that this is not really a smartest move, because the file input for MapReduce phase cannot predict the size that reducer will receive. For example, if you recollect our question on frequency computation of characters, if you recollect that, there computation of frequency of characters basically basically would result in a very small data that needs to be reduced, meaning their mappers will result in 26 numbers, correct, after the combiner. So there, no matter how big is the data, the amount of data that reaches the reducer is quite small, and therefore, you generally cannot predict number of reducers based on the input file size. You, but Pig does not have any other way to figure out how many reducers it it should create. So, as an intelligent guess, it tries to create one reduce per gigabyte size. If you have 10 gigabyte file, it will create 10 reducers. Okay. Okay, and it will keep on creating number of reducers. This philosophy is valid only up to 999 reducer. It creates maximum number of 999 reducer, not beyond that. Okay, so that's the algorithm of Pig. By default, it will create one reducer per gigabyte of input. Okay, up to 999 reducers. After that, it will not create any more reducers. Okay, so if we have 2 terabyte of file, how many reducers will it create? Sorry, so here if we have 2 terabyte of input file, by default how many reducers it will create? 2 terabyte, not 2 gigabyte. No, so Sanjay, it will be 999. Okay, it will not go beyond that. All right. Now next question, there are more questions coming up. How many reducers will it produce? Anyone? Or let me make it a little more interesting. All right. Now this question: how many reducers will it produce? Okay. I put a question mark in chat window so that I can differentiate between the answers. Anyone else? So it will create 0 reducers. Why? Because this does not require any reduce side code. All right. So if you see, do not impact mappers. If there is no reducer, then it will have no impact at all. The default parallel will have no impact at all. All right. Next question. Oh, actually, it was there only. Uh, yeah. Yeah. So we have already answered this one. Is everybody comfortable with it? The answer of this question. Does parallel have impact on this? Yes or no? All right, great. Because it's basically iterating through the input without any aggregation. All right. N- Okay. So there is another syntax called flatten. Flatten is just like group by, just opposite of group by, not just like group by, it's just opposite of group by. Imagine that you have key as Sandeep, which is a string, and then you have there is another field which is a bag. This is a bag with curly brackets containing multiple tuples. These are tuples. Now if you flatten it, what will happen is it will basically create multiple rows in this, meaning you will have Sandeep C++, Arun Shell, Arun C, C Money Java, and C Money C++. Okay. Now, why you might ask? So here we all understand that flatten is essentially opposite of group by. In group by, if we do group by of this one, what do we get is these elements for this particular key will group by. If we say group by column number 0 and this is the data set, then we'll get the result back. Okay. And when we say flatten, it basically flatten it. And we say for each generate first name and then flatten the second part, and this will basically flatten it and create so many rows. Now you might ask, what's the point? Okay, you might ask, like, what's the point of flattening? Now objective of flattening is that now on the resultant you can say things like limit, you can say things like filter, you can say things like order by, and so on. Correct? If you want to find out, now if you want to group the people by language, meaning find out who all are studying C, then we can now group it by languages, and all the people who are studying C will get grouped together. Okay. Yes. Makes sense. All right. Now the next part is, so flatten, Nitika, is, and does anybody else has doubt about flatten? So do you want me to explain flatten or the reason why we need flatten? Okay. All right. So if you look at the result of this one, now with the result, say, given this data, let's say this data is given, we are told Sandeep knows C and C++, while Arun knows Shell and C, Mani knows Mani knows Java and C, Java and C++. Now, if we want to find out who all knows C++, okay, in this data, or how many people are there who know C++, okay, so what will you do? Okay, in those cases, first you will have to flatten it, then group it by the language, and then do the count. Or you only want people who know C++. Okay, if you want only the people who know C++, again you will have to do is you will have to flatten it, and then you have to apply limit on it. You will say limit, so we will say here after this, so if we only want people who are, so we'll say only C++ equals filter P1 by language equals C++. Correct? So we can do a lot of these kind of operations. Hope is it clear? It is clear, Nitika? Good, good. Now moving on. Now at various point of time, you will realize that most of although the pig's library collection is huge, there are almost the functions for everything. So whatever you can do with SQL, you can also do in pig. Almost everything. But sometimes there are some functions which are not there in pig. In those cases, what should you do? Okay, you can get your development team, or if you are a good Java developer, you can create the function which can basically be run from pig. For example, let's have a look here. So for example, we want to run this function called toHex string. Okay, Java, there is a function called toHex string in case of Java. It basically takes integer and converts it into hexadecimal string. All right. Now here first we defined a function. First we defined a function using a define keyword saying define hex. This is the name of the new function. And then we say invoke this function for string, meaning return me the string. Okay. And then we can use this function as if it's a built-in function of our pig. Okay, so here we are calling a hexadecimal function from the base library of Java. Now what if you have your own legacy code that you want to be executed from pig? All right, then what you need to do is you need to register your jar, and then you define the function. Okay, and so on. All right, so I will show you how to create your own function in Java, and then everything will be clear to you. All right. Now, if you are good with Python, you can also use this kind of a syntax to execute Python function from inside of pig. So pig uses some bridge called Jython between Java and Python, and because you know that pig is written in Java, so essentially when you try to execute something from within Java, you may utilize Jython. So pig also does the same thing. Okay, so here when we say register a particular Python file containing our function using Jython as bball. So bball will be an object containing all the functions available in that Python file. And now whenever we want to call the function, we can call bball dot whatever function name is there. Okay, all right, so let's have a look at it. So this project I have already shared with all of you. Okay, so let's go to this page. So let me just see if it is coming or not. It's not coming. Let me go again. If you want to experiment with Eclipse, then this will be a good way. Okay. It's taking a little bit of time. So I think big UDF should be somewhere. So I can actually import it from there. File. So you can also click on import, and then you can say general, existing project into workspace, select the directory, and there would be somewhere the big UDF file. Here it is, yeah. Alright, so let me just see if it is somewhere. I'm hoping that it is downloaded. Yeah, let me just open it. Yeah. Good, good. So now let me import it. Yeah. So now we have a big UDF over here. So you can also do the same step. Download this zip file and open this. And here we have tried to create our own upper function. Okay, this is our upper function, which extends something called eval function. For every function you want to create using your Java code, you will have to create a class. Okay, you'll have to create a class that extends eval function, and then you will have to implement something called exec. Okay, exec will give you a tuple, or and that way you can basically return whatever you define here. So here our code is returning a string, and that's all. Okay, you will get a tuple as input, and out of the tuple you can get whatever value you want to take. Okay, and what is a tuple? A tuple is, you can imagine, like tuple is an array of elements. Fine, sounds good to you. So what is it that I'm trying to do? If the input is null, return null. If input size is, meaning there are 0 elements in this array, then return null. In case the 0th element of this array is not null, only in those cases, only in those cases you convert the 0th element from the input into string and then convert it to uppercase. That's all. Here we could do a lot more magic if we wanted. Here. Alright. So here we are just trying to do two uppercase. And now notice that we are in a package called myUDF, and we all know that whatever package we create, there has to be a folder onto the same. Yes, get 0 will give us the first column out of the tuple. Okay, so you can think of, let me go back to the question. So yeah, here this is the 0th tuple, and this is the first 0th value of the tuple, and this is the first value of the tuple. Okay, now what you can do with this is you can basically say export, export, and say jar file, and give the name to it like what do you call this? Pig udf.jar. Okay, and we say next. We don't give anything here. It says pig udf.jar already exists. Do you want to overwrite? Yes, I want to overwrite, and that's all. Now from here you can basically upload it to the server. We can say scp, and it, because it's lying in my downloads folder, so I can say pig udf over here. Alright, so I'm uploading this exported jar onto our server hadoop 1 dot nobigdata.com colon asgiri into my folder. Alright, done. So was it really that fast? Wow, interesting. How come it's too fast? Alright, let me log in to my server. SSH student at hadoop1 dot nobigdata.com. Okay, now here we launch pig, and what we do next is, so we downloaded the project, exported it. Next thing we do is we register whatever we have uploaded just now. So we say register pig dot pigudf.jar. Alright, now we will have our function, whatever we want to call. So let me see if it is existing somewhere. So we are loading a data from xyz a.txt into a, and we are defining that there is only one column in this input. And now we just try to dump. Now it says that it doesn't exist. Fail to read this data. Now, okay, let me also cd to my folder into HDFS. So if I say cd from my pig command prompt, it basically changes my default directory in HDFS. Now let me have a look. Does it have? Yeah, that one has this file. Now what does this file have? So we can simply say cat, and it has this. Let's convert this file into uppercase. Alright, let's convert this file into uppercase. So what we do is we loaded this file, and then we are calling our function to convert it to uppercase. Okay, and then we say dump b. Alright, let's hope that it works fine, works quickly. And also notice that it always tells you how many reducers are there as part of the input. Now it has converted all the values in the tuples to uppercase. Okay. Now what if, so can anybody help me understand that, how should I say, if we had multiple tuples in this file, okay? If we had multiple tuples in this file, it will only make the first string as uppercase. Sounds good to you? All right. Now sometimes you have this weird Perl script which has been in your organization for years. Okay? And I have seen this at Disha. We had lots of legacy code in Perl or in various kinds of languages. Okay? In all the legacy stuff. Okay. So there were a lot of legacy code in different languages, and there are even the legacy binaries which do something. So as we saw in streaming case, the Hadoop streaming, where we used the legacy binaries or any binary as MapReduce, in a similar fashion pig provides you a way to stream your data through the legacy code, through any binary per se. All right, and that you can do using a command called stream divs through this particular program, and this is what we are expecting. This is what we are expecting. Okay, so we say that we loaded the divs just like this, and then we streamed divs through this as, and whatever is the result, we are expecting the data in this format. And since if this command, say hidiv.pl, does not exist on every node, you can, before running this command, you can say ship. Okay, so you can define a function called hd, which is nothing but this particular command, and you can see that this command is also expecting these arguments. So you can specify that, and this is a backcode. So you can define your hd function as if it's a hd function like a command, which is essentially representing hidiv.pl executed with -r xyz. And this ship syntax, whenever we say ship, it essentially takes this Perl program and copies to all the node where our mapper code is going to get executed. Make sense to you? S- And when you are trying to execute this, you can simply say stream my data through HD, and we are expecting the result in this format. All right. So this is how you can integrate pig with the legacy code. Now, in lot of cases, you will find that there are already other people must have faced a similar challenge. If other people have faced a similar challenge and put their code in the piggy bank. Okay, piggy bank is nothing but a common source code library which you can download. Basically, you can check out just like we downloaded pig just now, our project. Similarly, you can also check out this piggy bank and compile the code and get what you want to do. All right. Yes, you can also use PHP code. Correct. Any code you want. All right. Now, there is something called for each nested. Okay. As we saw that for each is nothing but go through the whole list of records and project each record in some format. That's the role of for each. What if what if we want to go further into the values and iterate over the values? Say for example, here we have to find the counts of distinct name in each city. Say in Bangalore, the distinct name is Sandeep and Vivek, and if you count them, the distinct of them is Sandeep and Vivek, and if you count them, it's two. In New York, there's only one distinct name called Avan. Now, if you have to do this, okay, if you have to do this, what will you do? What kind of big script will you write in order to do that? Anyone? Okay, so let's take a 5 minutes quick break and come back at 9:36, 9:37 actually. All right. Yes, I'm back now. All right. So, Nitika, which till what point were you with me? And yeah, after which you want me to repeat? Can you tell me? No, no, last one. I don't remember which last one you're talking. So here I left you with a question. I left you with a question that how would you find the distinct names in each city? That's what I left you with. All right. So that was my last point. Before for each, as in for each is long, long back. Yeah. Yeah. So yeah, you can execute. So yeah, legacy code we talked about, and then we talked about piggy bank, and yeah, we talked about legacy code. Uh, you can execute any of the legacy code in the piggy script. Then we talked about something called piggy bank, and then we talked about for each nested. Yeah, you can go through the video. Okay, this is getting recorded. I hope that nothing wrong happens here. All right. Now, question here is, and yeah, so this would and Nitika, this would not impact if you have not gone through the legacy code part or piggy bank part. Then this won't impact anything right now. All right. So you can yeah. Any questions here? No questions? All right. So my question to all of you is, if you have to find out distinct names in each city, and this is the data you're given the name of the people and the name of the city. So how would you find the distinct name using pick? Anyone? Okay. So we say group by and then good. Group by city, that is correct. Yes. All right. So first you do group by, and then after grouping, what will happen is for Bangalore, Sandeep, comma Vivek, that will be the bag, and for New York, it will be the bag would contain John, comma John. Okay. Now this bag which we just created by the virtue of group by, what if we want to iterate over this bag? Okay, what if we want to iterate over each group and want to execute each of the functions which we have studied earlier, like filter and further group by, or we want to basically inside the records, if we want to do these row based operations, so if you look at it, group is basically a function which we apply on the whole table, or which we apply on the rows. If we want to apply the group by inside the group by, okay, so that's where the nested for each loop comes into play. Look at this. After we have grouped the data, after we have grouped the data, we will have something like this. Okay. So if this is our data after grouping, this is what it would look like. This will look like Bangalore, and then tab, and then Sandeep, comma, Vivek. Okay. And then we will have NYC, and we'll have John, comma, John. Now this is the data set. Now on this kind of data set, the you can apply the various kinds of functions which Pig allows. But what if you want to apply those kind of function on these values? Okay, on these values. In those cases, you will have to use for each nested. So for each nested basically picks up this record and gives you this group. I mean, whatever is the values, you can you can basically execute various functions like distinct, and other functions like filter on top of any of these any of these values. Okay, so that's where the for each nested comes into play. This is specifically needed when this list is really huge. Okay, so we can further say a for each inside a for each. That's where the for each nested comes into play. So instead of just saying generate, we put curly brackets, and after you put the curly brackets, and we basically get the access to the values in the group, and on the values you can apply the functions like distinct. Okay, and after you have done distinct, then you can say count here, and that's all right. So this is what we call a for each. So basically for each makes it possible to nest another for each inside it if you put curly brackets, and that is the reason why for this is called for each nested, just because of this syntax. All right, is everyone with me? No? So only 3 people are with me in the class. Only 3%. All right. All right. Now here, so this was for each nested. So point number 3 and 4. So what am I trying to do here is, inside for each, you can put another for each, or you can execute functions like distinct on top of your data. Okay. So you mean to say this one, 3 and 4. Which point number 3, Tarak? Okay. Alright, so from here to here you can see earlier we could only do generate, which was projection, but now for each record we can further treat each record or each bag as if it's a group. It's you know uh, a data set, and further apply the functions like distinct. Alright, if you put the curly brackets there. Alright, so that's for each nested. Now this is something interesting. So imagine that you had a huge table containing names of people, and the second column in this table is the name of the country. And now what you want to do is you want to replace the country's name with country's ISD code. You want to replace the country's name with the country's ISD code. And roughly there are how many countries? Anyone? Roughly around 200 countries. Let's assume, okay? And for 200 countries, this mapping between the country code and ISD code will be hardly 200 or maybe 500 bytes, which is hardly 1 kilobyte. Okay, so mapping between the country name code and the ISD code would be hardly maybe 1 kilobyte. Okay, now say you want to convert, and how many people would be there? Let's assume that there are a billion entries in this. So is the problem statement clear? You have got billion entries in a table in which you want to translate the country's code into ISD code. All you want is a table of billion entries where there is a name and the ISD code. Now, question to you is, how would you do it using Pig, and how would you optimize using MapReduce? Anyone? If you have to do it using MapReduce, let's assume, what will you do? Can you take the benefit of the information that the second table is really very small? Okay. So anybody who has thought about this? You have a billion entries in a table. First column in this table is the name of the person, and second column is the country code. Now you want to translate the country code into ISD code. Okay. Can anybody suggest me a strategy which is really efficient? Anyone? Okay. So Nitika is saying that by using joins, good. So by using joins, we could join these two tables. And how does joins happen? Joins happen the way on whatever you column you want to join the two tables, you make that your key, okay, in the map reduce. And then the Hadoop will group them together, and in the reducer code, you will basically in the reducer code, you will basically bring all the values together, right? Now, if you see here, we could do better. The second table is really small. Can we think of some way? Some way where we don't even need the reducer code. Anyone? Make the country as the key, okay, and name as the value, okay, and then replace key with the country code. But how would you replace? That is my question. So you are saying that in this table, we say we pick the name and the value. How, I mean, suggest me a way to replace that. So your mapper is giving out, I agree, that country as the key and name as the value, and then replace key with the country code. Okay. And okay, let me just think about what you're trying to say. So you have already loaded the second table into memory. How are you doing this replacement? So for every country code, you're looking into the second table and then print it. Is that what you're doing? Correct. Mm-hmm. Okay. Mm-hmm. That's also interesting approach. What Shweta is suggesting, but she's suggesting that group this data by country, and then, but if you see the moment you say group, right, there is going to be reducer side code, and there is going to be the whole data being read, and essentially grouping will be a little heavy operation. Yeah. Can't we just read the one as we are reading this 1 billion entries? We can just replace these country code. Can we just keep the this table of country code and the IST code in the memory because it's just 1 kilobyte, and then only have mapper, no reducer. Anybody? All right. So yeah. So the general strategy in this case is since we are trying to join the two tables, so joining will be the standard way. But joining is a fairly expensive thing because second table is treated equally, and then you try to do map and reduce phase is there. Instead instead, if we just load this country code to IST code mapping into the memory, and in the mapper we just go record by record, and as we are given the record, we just spit out the we just look up into the our map and then give out the IST code, and that's all. Okay, we have no reducer, no nothing else, and we turn off the sorting also. So does it make sense to you? So that's exactly pig allows you to do by the way of saying fragmented. Okay, so instead of you coding it just for the sake of optimization, so and all of you keep in mind that almost every big data problem is all about optimization. Okay, you cannot say that it's okay to have optimization. No, it is must to have optimization in these circumstances, because when we talk about a billion entries, there will be a difference of maybe few hours, or maybe like 6 hours or 10 hours when we deal with our problems in big data. Okay, and 6 hours is a huge time. So your minor optimization can result in hundreds of hours of computational time. Okay, it can save a lot of time for you. Now in this here, if you look at here, we say join these two tables. It's essentially looking like a join. It's just that the table which is smaller, we with it we say using replicated, meaning load this second table into the memory and then do the join. So it's a special kind of a join. It's not your normal join. It's a special kind of join called replicated join or fragmented join. Okay. So essentially, the second table gets loaded into the memory on all nodes running the mappers, and then it will replace the values. It will do the join. So everything will happen in the mapper. There'll be no reducer involved in this process. Okay. So here we are saying we created two tables. First one is we loaded persons, the first table. Then we created second table, loaded second table, and then say join persons by country, comma, CC by country. So we are trying to join this table and this table and marking that this table is replicated. And the moment we say replicated, Pig figures out that instead of using the normal joins, we will load the second table in the memory and finish the okay. Yeah, that's correct, Sweta. It would be something like result equals okay for each joined generate name comma code. All right, it'll be something like this. So the output of the third statement would be okay. Can anybody help me in this? The output of third statement would be, I'll show you what will be the output. So let's I'm just trying to copy this data. Okay, let's say this data is there and this data is there. So the result of this one will be, oh, I can't paste it. Never mind, I'll just paste it here. So result of the second statement would be this. This is what it will look like. The joined table here, joined, would look like this. Okay? Why? Because there is one table here. For in, it will find out this record and both the columns will be there from both the rows and so on. And when we say for each over this, we are picking only one column. Okay? So we can say country.name here. Persons, join persons by country. So we say persons.name and then we say CC by code. So everybody with me in this? Great, great. Nitika? All right. So that was one optimization, and it's actually a very big deal when you are dealing with big data. Having this kind of a small optimization is a very, very big deal. And now, by now, you would have understood the reason why people use Pig Latin over SQL. Because in SQL, there is no way to introduce this kind of a syntax. Yeah. So replicated keywords does the changes the whole behavior the way pig does the joins. Instead of using the usual map reduce, it loads the second table into the memory and replaces the value, or combines the value instead of doing the usual map reduce. All right, I hope you understand that. All right, moving ahead. Now, joining the skewed data, there'll be a time where you will find that for some people the data I mean, in this world, if you're dealing with a lot of data, for some keys there'll be so many values, billions of values, and for some keys there'll be only 2 3 values. Okay, so, and for some keys, and in these cases, whenever the keys for one sorry values for one key is million times the values of another key, then we call our data as humongously skewed. For example for example there is total number of users in one city could be million times more than another city, correct? And therefore, whenever you are joining two tables, it is important to mark it as skewed. Otherwise pig will be very very inefficient. Why? Because the way it groups the data is, I mean, that will become really really tough, you know. So basically, skewed makes it possible to handle a huge discrepancy between the one record and the another. So for example, we are joining users and the city info on city, correct? And when we are joining on the city, so it is going to under the hood, it is going to create the the key value pairs out of the mapper based on city as the key. And when that happens, for some cities there will be millions of users, and for some cities there will be only few users, correct? And therefore the values are very very skewed in the nature. So if pig attempts its own usual aggregation, own usual reducer, then what will happen is the reducer will badly crash, because for some users it will be only few keys, and for some users it will be so many. Sorry, for some cities it will be so many. There will be so many users. Okay, and for some city there will be few users, and because of this skewed nature, normal joins will be very very inefficient. To speed it up to make it uh, such that it attempts a couple of new tactics. If you remember our problem of the problem where we were trying to find the tuples, so there was one problem statement that for some of the keywords such as is, am, are, the word that follows them will be millions. While for some of the keywords like name of the people, the number of words that follow them will be few. And hence they'll be humongously skewed of data. So the usual map reduce where key is based on something would not work. It has to be attempted a little differently, and that little different strategy is taken only if you mark it skewed. All right, make sense? Great. Now, Lot of times you will realize that the data you are trying to join, it is already sorted on the key you are trying to join. Then, is there a way that we can tell Pig that, hey, our data is already sorted? You don't need to sort it again. Okay? So, again, visualize in the head that how is Pig going to join two data sets? It is going to basically it is going to take two data sets, make the key as the column on which we are trying to join the data, and then concatenates the two and passes to Hadoop, and Hadoop sorts the data on that key, and after sorting in the reducer, it combines the data. So if you look at it closely, what's happening exactly is, yeah, that's a very good question, Sweta. Yeah, I'll try to explain that. Let me just finish the sorted part. So essentially, when you are joining under the hood, a lot of sorting is happening. If our data is already sorted, then there is no point of sorting it again. Now, if you so using the using this keyword called merge, if we say this, then Pig will assume that our data is already sorted. We don't have to again sort it. We just pass it, whatever input is given to us, we just pass it to Hadoop as is, and then we just reduce it. All right, so those are the optimizations that are possible. I will try to answer Sweta's question in a while. Let me also talk a little bit about sorting. So, let me ask you a question. So, there is a data set which has got 1 million records. Okay, there is a data set containing 1 million records. You sort it, and it takes B equals sort A, it takes, say, 20 seconds. Okay, now C equals sorting the already sorted data would take how much time? How much time? Can anybody suggest? Will it be how much time? Okay. And A is, option A is less than 20 seconds. B is 20 seconds. C is, okay. So, right, I think I should make it just 0 seconds, and B is 20 seconds or more. Yeah, so there are two options. So Sweta says A, Nitika A, Vikas A, Amar and Malvika B, Bob says B, and Abhishek says B. Anybody else? Tarak? Great, great. And Sanjay, are you with me? Huda, are you listening? Yeah. So do you think it's A or B? Sorting A took 20 seconds, and now we are sorting B, which is already sorted. Okay. which is already sorted. So how much time do you think it will take? We are sorting on the same key. We are sorting parameters are same. So it will take 0 seconds, or it will say take close to 20 seconds or more. Anybody quickly? No. Actually, it's B. So sorting the sorted data is actually a horrible thing. Sorted the sorting data is actually a very horrible thing, because imagine the binary search tree. If you guys have heard about a binary search tree, so read it a little bit. Whenever we are sorting the data, algorithm cannot detect that it was already sorted, and it needs to avoid sorting. Okay, so no algorithm can detect that it's already sorted. Even if somebody tries to detect, that algorithm will itself will become so inefficient that it always try to figure out and unnecessarily waste time. Okay, so almost every sorting algorithm takes about same amount of time applied on sorted or unsorted. Okay, but some of the algorithm take humongously humongously big time to sort the sorted data. One of them was the usual binary search tree. The usual binary search tree for sorting the data is actually very slow if you are trying to sort the sorted data. Yeah. Yes. So now Sweta's question is that what if it basically in the first iteration it tries to figure that out. Now imagine this same algorithm being applied on unsorted data, and every time before trying to sort it, it tries to identify that whether the data is already sorted or not. So if you amortize it, meaning think about the billions of execution of that function again and again, you will realize that it's a total waste of time. Okay, so this part is generally left to the developer. Not that developer should not try to sort already sorted data. Okay, so those who are still confused about this, let me try to see if I can explain. Okay, now let me make it a little bigger. Yeah, so imagine that in a binary search tree, what we are trying to do, let's say we have 1 comma 2 comma 3 comma 5 comma 6 comma 8. Okay, and we are trying to create a binary tree around it. Okay, so first time 1 comes into play, it will create a node 1. When 2 comes into play, it'll create a node on the right hand side. Then when we try to, let me draw something that'll look cool. Okay, here. And generally, had something come which is lesser than 1, we could have put it on the left hand side. But since uh, it's greater than 1, we are adding it on the right hand side. Again, when 3 comes into play, we put it on the right hand side, which is say 3. When 5 comes into play, we will have to again. So how is it happening? So we are trying to insert 5. So we'll check with the head of the tree whether 5 is greater than 1 or less than 1. If it is greater than 1, we have to insert on the right hand side. Now again we went to right hand side and there is an element existing. We again check whether 5 is bigger than 2 or lesser than 2. Then again it goes to the right hand side. Again it compares here and so on. And this keeps on going. And now you can imagine that for inserting the inserting 8, it is going to go and compare against each value, which basically leads to a very, very inefficient algorithm. Okay, so if you see, for inserting 8 we had to go through all the elements. For inserting 6 we had to go through all these elements and so on. So if you try to count, it's the order of this is close to n square. It's taking more time than the unsorted data. That's correct. Now, if you look at it quickly, had this been a different scenario, same one, like here, let me just copy it and imagine that it had been like little bit shuffled. Okay, it had been little shuffled. Okay, it had been little shuffled. Okay, like this. Now look at the tree, the way it's generated. So inserting first element, the time is going to be similar. Okay, and how can I delete everything? Okay, here. Yeah, I can put, yeah. Let's see what happens. So for inserting 5 in this tree, this binary search tree, we are creating a node called 5. Now we will insert 1 because 1 is lesser than 5. So we are going to insert it on the left hand side. Left hand side. Okay. And now next comes 5. For 5, sorry, 6. 6 is going to be on the right hand side because 6 is bigger than 5. Okay. Now comes 2. 2 is 2 is compared. This is our root node. Okay. This is our root node. Now 2 comes in, and when we try to insert 2, it is on the left hand side, and hence it goes and compares it with the 1, and then we put it like this. Okay. Now, if you see that, since the tree is fairly, let me again try. So now for 3, it goes here and compare here and so on, and we have 3 here, which is looks like this, and we have 6. All right. We have 8 now. 8 is greater than 5 and greater than 6, so 8 will be here. So now if you look at it, for inserting 8, we had to only do one comparison, two comparisons. For inserting 1, we had to do only one comparison. In case of 3, we had to do 1, 2, 3 comparisons. Earlier, the total number of comparisons we had to do were really, really high. Okay. Okay. So basically, although most of new algorithms of new times are have been designed such that they do not fall into this kind of a trap. Okay, they do not fall into this kind of trap. Most of new algorithms are designed on this, such that they keep on rebalancing their trees when the tree is getting unbalanced, like red and black tree and other trees. So most of the algorithms are designed in that way. Okay. So, and these algorithms take equal amount of time whether this is unsorted or sorted. Okay. So now let me, so was that explanation clear to you? All right, good. Now, Goyal's question is how to know whether the data we have got is sorted or unsorted. If you do not know whether your data is sorted or unsorted, treat it like unsorted. Okay? Treat it like unsorted. Now, let me go back here. And if you yourself have sorted earlier, say you have joined the data and you have saved it, and you know that this data resulted because of my order by clause. That means if you know it, then you consider the merge instead of sorting. Okay. Now coming back to a question asked by Sweta, that's an interesting question, and that is something that would require a little bit more advanced way of looking at things. Okay. If for some keys the values are hues and you need to do processing, so what you do is you choose different keys, as in you combine key and value to form the keys, and then try to see if they can remove the duplicates or something. So there is a lot of engineering that goes behind it. Okay, so let's say, how should I describe it? Let me try. Okay, now, so in our previous assignment where we were trying to find out the suggestions after a particular keyword, we were preparing first word and second word kind of a tuple. Okay, and so for the keyword like is and the general prepositions, there would be hundreds of uh, 10,000s of values or millions of values. Okay. While for name like Sandeep, the keyword that follow would be few. Okay. Maybe few entries. Okay. Now, if we had to compute the number of words that follow is and Sandeep, then what would we do is first we try to remove the duplicates. Okay. Try to remove the duplicates. So instead of making this as a key, we'll make this as the key. Is dash Giri, is dash girl, and so on. And here also. And then we will do the count first on this. Okay. And then we break it again into the key and then run the whole thing again. So those are few sophisticated MapReduce techniques that you can apply when your values becomes really, really huge. Okay. So in the same manner, Pig will also try to do the skewed joins. All right. Sweta, are you with me? No? Good. All right. So there are a few more sophisticated techniques that would actually go beyond what we have. Yeah. I'm answering to Tarak. Is it composite key? In this case, yes. So we tried to create first composite key, did the deduplication, we removed duplicates, and then we got our values smaller, and then we did the other processing. Okay. All right, so let me go ahead and so mostly what people noticed was whenever people are joining tables in Pig, they are also grouping them on the same column. Okay, most of the people are trying to join the two table as well as group on the same column. If you try to join on the same two column and then group, then you are basically sorting the sorted data twice. Okay, you're trying to sort the data twice, meaning first you joined it, joining also sorted the same data on the same key, and then you are trying to group it on the same key, then it will sort it again. Correct? Therefore, and this was a very frequent exercise, and so we came up with this syntax called co-group. So co-group basically combines the join as well as group by together. Let's have a look at this. So it basically co-group basically groups the two table by a column and then join on the grouped column. Look at this. So we are saying co-group owners and pets on the column called animal. So this is owners and this is pets. And on animal, which is second one, which means first let's group it, meaning for cat there is Adam and Alice, and for cat here, similarly, we have paws and whiskers. So, for cat, effectively, you have got these. Alright? So, you can see this. This is what it is. So, Alice and Adam, and whiskers and paws. Whiskers and paws. So sometimes you need to bring all the data together as well as group it on the same column on which you are joining the two tables. In those cases, co-group is really brilliant. All right. Although you could do few things like join the two tables later on, first group the two tables independently and then join the two tables with merge. That could have the same impact because merge will not let the sorting happen again. Okay, all right, so moving on, if you have two tables A and B and you want to combine the two tables one top of another, union is the way. Okay, so let's have a look at it. How does it look? So imagine that we are loading two files, input 1 and input 2. Let me just say ls cat A and cat B. Mm, where is my data? So we have cat B here. No. Yeah, this is good. Now I'm going back there. I'm saying from local, copy from local .b into sgiri. Okay, now I'm going into sgiri folder on hdfs. Now there will be A and there will be B. Now we have got these two tables, A and B. All right. Is everyone with me? Now imagine this. We say A equals load A as, okay, we say as x comma y, B equals load B as x comma z, or z comma x, okay, z comma x, z comma x. Now let's say we are unioning them together. We are saying union A comma B. So what will union contain? Look at this data set clearly. It says A11, A12, A21, A22, and B is also some data. Now we say dump C. We say dump C. So you get these records from A and records from B. You see this? It just put the records of one on top of another. That's all. So normal union should be clear to everyone. Now there is something called D equals. Okay, let's save this result. Okay, let me save this result for you because this is going to be quite handy. This is again, yeah, this one. This was our grunt, and we said, what did we say? We said dump C. Okay, so this was our result in case of C, and this is A, this is B. All right, so union A comma B only puts some record from one on top of another. That's all. Now also notice that we will show you this. Describe A. A has two columns x and y, and describe B. B has column z and an x. Now we say D equals union A comma B, and we say on schema. Okay, and say dump D. What would happen? It will try to match the scheme, meaning it will try to put all the columns which belong to Z under the column called Z, and it'll try to also join the, basically based on the name and the data type of the column, it will try to merge them together. I'll show you, just let it run. So our A had two columns. Okay, now look at this. Look at this. So so D is this, and dump D resulted in this. Now you can see that this column is empty, and this column is empty. This column is full, and okay. So what does describe D says? Describe D says that D has got three columns, X, Y, and Z, and describe A says it has got X and Y. Describe B says Y and Z. So what will it try to do? It will take the data from second column of B, put it under X, and indeed will create total number of three columns, X, Y, and Z, and all the values belonging to X will go into here from both the data sets, and so on. Basically, it is trying to match the schema. Is it clear to everyone? So it has left those columns blank, okay? Because Y does not exist in B and the Z does not exist in A. So it tries to put the values from both the sides. Yeah. So here what is it trying to do is it picked all the columns from A, all the columns from B, created a table from this containing all three columns, then picked up all the values from A, put it under D, X column here, and so on. Okay, I think a better way to visualize this would be an Excel sheet. Let me show you. Yeah, here we are. So let's say X was here, okay, and X has this data. Ouch. Never mind. Okay, so this is our A, and A's scheme is X and Y, and we have got B. B looks like this, and B was Z and X. Okay, and when we say union on schema, it basically created three column set out of this, and that one looks like our X, Y, Z, X, Y, Z. Alright, now when we try to do it, it takes these records and tries to fit in, and incidentally it just tries to fit in this part first. Okay, or let me just copy it. So X goes under X and these go under Z. Now it picks up these columns, and here we go. Alright, now you can see that these columns are blank. Okay, these columns are blank, and these columns are also blank. Alright, this is the result of on schema union. Is everyone with me? Awesome. Yeah, correct. Alright, so this is probably the easiest way to understand on schema union. All right, and yeah, okay. Again, a quick teaser to everybody. So C equals join A comma B. What is the result? Anyone? Um, okay. Does anybody wants to take a break? Let's be back at 10:50 p.m. IST. Break for 5 minutes. All right, so let's start. So anybody, what will be the result of join A comma B? Anyone? Quickly. Yeah. We discussed it earlier also. Yes. So when we discussed about joins, when we are joining two tables in Pig, what actually happens? Yes, correct. But and sorting requires some criteria to sort upon, isn't it? Right? Now, so the you will get an error here. Reason being, whenever we joined, we always specify a column on which we need to join the two tables. We need to specify a field or a column on which we are trying to join the two tables, isn't it? We say join A by X and B by Y and so on. Unlike in SQL where it results in cross product. Okay? If you have a table containing, if you have a table A, or let's say we call them adjectives, which is good, bad, and we have another table which contains nouns, which is boy and a girl. And if we want to generate, if we say select star from adjectives, comma nouns, what do we get? What we get is all a combination of good boy, good girl, and bad boy and bad girl, right? So we get all these combinations out of this, correct? And that is the magic of SQL. And here in Pig, as we talked about earlier, the joins need to have a column on which to sort. Also, joins cannot have a condition on which to sort. There has to be always a column on which to join. Therefore, Pig had to come up with another syntax called cross product. Okay, we could say cross here. Here we could say similar thing. We could say cross adjectives, comma nouns. So we could say this. This will produce the same result as above. And here the parallel syntax is also valid here, similar to group by and similar to joins. The parallel syntax remains there anyway. Okay, which basically controls how many reducers will be used for doing this kind of cross joins. All right. Now the usual parameter substitution. Since pig is heavily used in case of reporting, and when you are reporting or when you are generating reports or you are running something every day or every now and then for different data sets, you might want to pass a argument, or you can say parameter. If you have ever done the business intelligence reporting, the BERT or Crystal report or any other, everywhere most of these reports are executed every night. And while the reports are getting executed, you always pass some arguments to the report. Okay? And So that's a very common thing. Similarly, this pig script is going to be executed in the similar manner, and you would like to provide the arguments, the parameters to your pig script. You can provide that using something like this. Inside your pig Latin code, you can write a clause like filter something based on this, and instead of hard coding a value, you can say dollar, meaning expect this value as parameter, expect this value as command line argument. And when you execute this script, the way you do it is you use pig minus p and then provide that value for the parameters and then execute daily.pig. This is our daily.pig. Now, when it gets executed, here the value is going to be 2009-12-17. All right. So if you want to execute the same script with 10 different dates, you can do that without having to modify this file. Okay, without having to modify this file. All right. So that's a parameter substitution. And sometimes what happens is you have in a single script, you have say 10, 15 arguments. Okay. In those cases, you basically create a separate file called parameter file and pass that file in the arguments while executing the script. All right. Next is a split command. If you have already one file loaded into a data set or in a relation like wlogs, and you want to break it into multiple uh, multiple data sets such as April 03, April 02, April 01, okay, based on various criterias. You could use a split. Okay. Otherwise, other criteria could have been we load it once and we say April 01 equals to for each, we run the for each and we generate these. Okay. So basically, based on this criteria, these records will be copied to April 03, or based on this criteria which you see here, based on this criteria, April 02 will be filled and April 01 will be filled based on this criteria. So this is called splitting one data set into multiple. Please note that this split is a little misnomer. When we split something, the things are mutually exclusive. Here it's not the case. One record can go into multiple of these data sets, or a record may go into none of these data sets. All right. As you can see here, this condition is satisfied by for some record for the April date, the condition is satisfied by this, not this. Yeah, all the records that satisfy this condition also satisfy this condition. Okay, so the record will be copied twice, one here, other here. All right, this is called splitting. You can split one data set into multiple other data sets. All right. All right. So again, this is the thing which we already emphasized. The execution of pig script is not linear. What does it mean? It does not get execute the scripts in the way a C code is executed. Okay, meaning it starts from top and keep executing till bottom. No, the execution starts the moment you say dump or store, and it finds out all the dependencies and executes them one by one. For example, and okay, we have deleted that data set. So for example, we say A equals load A, right? And B equals filter A on some criteria, and C equals order B by some criteria, and so on. All right, are you guys with me? So here, what when we say dump C, it will execute all of them. This will this will this will execute the following: A, comma B, and then C. Okay, but if you say dump B, it will not, or let me put it this way, there is another thing called D equals filter B by something. Okay, so if you say dump D here, so dump D, this dump D will not execute the line number 3. Dump D will not execute line number 3. Okay, so therefore the execution is non-linear. The execution of pig statements is non-linear. Also, a single when pig is generating map and reduce phases, it tries to combine multiple things together. Okay, a single map might be spread across multiple operations in pig Latin. Okay, as well as in case of a reduce phase also multiple things could be done together. All right, for example, if you look at this statement 3, okay, so first we are filtering A, then filtering B, sorry, we are loading A and then filtering A and B. So what if while dumping D, these two filters are combined together into a single map? That will reduce load a lot. Yes. So it intelligently identifies in what order to execute in and what to execute. Also, it figures out what to combine together in a one map phase and what to do in the next map phase. So it does a lot of optimization in terms of the execution. All right. So that was pretty much about Pig Latin. You go through this general documentation that should give you a really good overview, and also you might want to go ahead and look at how the custom load functions work. That should give you a good overview of custom load functions. All right. So that's pretty much about Pig. Using this knowledge, you can probably do everything that is needed in case of Pig. All right. So now you can finish all the assignment related to Pig, and let me now. Yeah, voice is not gone. I'm just silent. I'm trying to open the Hadoop session 6. Or am I audible? Or is it just for Nitika? Yeah. All right, so that was pretty much about pig and pig Latin. Now let's talk something about Hive. All right. So today we are going to now talk about what exactly is Hive and how does it help and where is the gap between the two. All right. So we will talk about Hive and we'll also compare with Pig and we'll compare with MapReduce and see what all Hive can offer us. Okay. So the general question is that which people ask me that Hadoop is great, but how can you move existing database developer onto MapReduce or onto Piglatin? It's not only it's not only the data which is so already there are a lot of data lying in SQL databases and hence lot of people are very comfortable in SQL. And what I found is lots of people may not be comfortable with programming, but they are very comfortable when it comes to SQL. And that is the single most thing, the knowledge which is most common found in people, that they know about the databases. Okay, so there's a lot of SQL infrastructure. There are large bases of users and their database designers and architects. How can you move them to Hadoop? Okay, so while on one hand we have MapReduce, which is itself even difficult for developers, and there's a lot of repetitive logic such as join and group by we saw in MapReduce. It's fairly repetitive logic and not really efficient in a high turnaround time. If the turnaround time is turnaround time required is really high, meaning we need the output immediately, then MapReduce is out of question. Okay. So since we cannot move the existing users from SQL away, we'll have to have we'll have to use things like Hive. That's the reason why Hive is in use. Okay. Hive makes it possible to execute SQL queries to churn the data lying on HDFS, HBase, okay, and other big data infrastructure. Okay. And also note that Hive is mostly the read-only operations. It's not very it's not for writing the data. Okay. So the value proposition of Hadoop is that it's mostly suited for data warehouses. It's mostly suited for data warehouses where you have to statically analyze the data, meaning the data is not changing very much. You have to analyze the relatively static data, and you don't require the fast response. Why? Because under the hood it's Hadoop, and under the hood it's the same MapReduce, which is batch wise, where the execution is based on the availability on the resources instead of immediately. Okay, so whenever you don't require fast response time or you are analyzing sort of a static data, then then this Hive kind of solution is good. and it also makes it easier to port the existing projects. And Hive also provide the Hive is basically a very compatible with existing queries, and we call it Hive QL. Also note that there is one more component. Just like in case of a pig, we only had we only had something called pigletin. We did not have any service which is running over there. Pig was just a client. Pig was just a client, nothing more than that. But in case of Hive, there is something called meta store also. And this meta store basically keeps the definition intact. A- As we saw in pig, the way we loaded data, A equals load something and B equals filter something. If you exit the pig prompt, all of that information is gone unless you store it in HDFS. Otherwise, all of this information is gone. But in case of Hive, all of that information, like the tables you have created and all of that, is stored in Metastore. Okay, Metastore is nothing but MySQL database, and that's how it works. And Hive provides you querying the HDFS files and HBase. Now, the limitations are important to understand before we start. It does not provide you insert or update. Okay, it does not provide you insert or update, although you can create the full table, but you cannot do things like insert into this table and few records, or insert into this table values are these. No, you can't do that. Similarly, we cannot delete. Okay, so yes, it's mostly select, or you can create the whole table. You can say select star from this into a newer table. Also, Hive is not suitable for OLTP. OLTP is online transaction processing systems, because all OLTP systems demand really high response. They need immediate response. Okay, and in those cases you cannot use Hive because first, it takes a lot of time to execute the query. There's a latency involved, meaning every MapReduce job takes around 3 to 4 seconds even to start. Second, the MapReduce is built around the idea of strong resilience, meaning in case something fails, the work will be sent to somebody else. Okay, so the whole philosophy with respect to MapReduce is to get the work done no matter how much time does it take. All right, but in case of OLTP, the behavior of the component should be get the work done now or give me the error. Okay, therefore it does not make sense to use Hive in OLTP situations. And it's best when large data set is maintained and mined. All right, any questions till now? We talked about general propositions. Why do we need Hive, and why do we basically what we cannot do with Hive. So Tarak's question is, can you give a live example in which case Hive is being used? Okay, so for example, in case of a sentiment analysis, which we will do in this project, all the data which we have downloaded from Twitter, we will load it into Hive, and then we can query it. Okay, and as of today, most of these existing organizations are actually very comfortable using Hive. Why? Because the talent is already available for Hive as opposed to Pig or MapReduce. All right. Now, you might ask that then what's the point of Pig Latin if we have Hive already? The reason behind Pig Latin is Pig Latin is far more efficient as compared to SQL. Okay, and you can really write you can actually write more efficient code in Pig Latin as compared to Hive. All right. Now this is the ecosystem of Hive. At the bottom, you see here you see Hive. There is a master. I mean, there is Hadoop, basically the base. So because at the end of day, everything gets routed to Hadoop MapReduce. Okay, whether it's Hive or Pig, everybody creates the MapReduce code and executes it on Hadoop. Nitika's question is that why we need Hive. So if we see the first slide, what was the first slide? There, since there are lots of people who are very comfortable with SQL, instead, so it's very difficult for us to change, for Hadoop to change the world immediately. There are lots of people who have very great expertise, as well as there's lot of SQL code written by lots of people, and porting that code to Pig will take enormous amount of effort, but porting that code to Hive will be very quick, and that is why we need Hive. All right. So here in this diagram, at the bottom is your Hadoop ecosystem that will execute your MapReduce anyway, and then there is a driver. Driver basically is the one which takes the query, which takes SQL query and converts it into MapReduce. All right, converts it into MapReduce and get it executed on Hadoop, and then gives the result back to the caller. And this driver basically does everything. It starts with compiling your code, your SQL script, then optimizes and then executes it, and then gives result back to the caller. And who all are the caller? The callers are the CLI, which is command line interface, high web interface, which we will show you, and third one is the thrift server. The thrift server. Okay. Now, what does this metastore do? So the storage about the intermittent tables, the tables which we will create, it does not get washed away. We don't have to create these tables again and again when we are executing our queries. These tables are persisted inside this metastore. All right, these tables are persisted inside the metastore. Okay, now what is the thrift server? Thrift server is a generic server which is very heavily efficient, and whenever you are providing service or you are providing a service API, a service layer, instead of providing different so basically whenever you're providing service, you use thrift server. Okay, because thrift server gives you gives you a number of clients in number of programming language which you can call at any point of time. So whenever you are building a service API, it is advisable from my side personally that you use thrift server kind of a layer where you just implement the backend and you just implement a contract and it generates all kinds of clients in all kind of languages. It generates the clients using your intermediate definition language. Okay, so that's a thrift server. It's not unique to Hive. It's a common for almost all the components. Thrift server came from Twitter. There was from the Twitter development team. They made it open source, and thrift server is really fast and very efficient, and is great when it comes to providing service API. All right, so this diagram is clear to everybody. And then on the top of it, there are web interfaces like Hue, we will show you. And then we have a Cubole kind of web interface, and there are others. So these are the various modules available. All right. Now, the, the traditional code, this is how the SQL code looks like for our word count example. Here you can see that we we basically picked our data. First, we loaded our data into one table. You can see that. We loaded the data into docs, and then from the docs, we splitted the word and then exploded and then grouped by and then did the word count. So this is how our SQL query looks like for word count. All right. All right, to get started, you can simply SSH to any of these machines and then start working right away. Or you could go to the web interface, which is not this, which is 8000. And you can say, click on Hive UI and start writing your query over here. You can select your database. Also, you can actually create your own database and then start working. Okay. If you go to Hive catalog, you can create your new database from here. Okay. Also, from here also, you can say show databases. This is Hive interface. So these are the database available. You can create your own database using create database and giving the database name. Okay. We don't have to put these quotes, I think. Yeah, it has created. Then we can say use this or drop database. All right. So this way you can also create your own database and start working on it. All right. So also you can try executing a very hello world kind of example. Here I'm using my own database. So it's done. So you created a table with one column as integer. Then we selected the data from it and then dropped it. That was the most simple query that was possible. Okay. Also, a little bit about the Hive command prompt. Just like at pig command prompt, we were able to execute the HDFS command. Similarly, here also we can execute commands using DFS. Okay, so it shows us the files located in HDFS. All right. Also, you can load the SQL queries using source. If you have another SQL queries lying in a file, you can load that. Also, the commands start with double dash, and it also has similar to pig. It also has a way of passing the parameters and executing various kinds of queries. Okay. And if you want to execute something locally, you can put exclamation and say execute that command. Okay, these are local files. All right. Now here, all right. So is everyone with me? There are various kinds of data types that are provided by Hive, and most of these data types are being added as and when the Hive is growing. Okay. So for example, these are the various data types possible. Tiny int, small int, big int, float. So it is started with simple, very simple data types, but in order to being compatible with other databases, and why are we trying to be compatible with other databases? Because their SQL queries are in those databases, right? So if as this Hive is compatible with their data types, it will be very easy to translate those queries into Hive. Therefore, Hive tries to support all kinds of data types. So binary and booleans both are same, but it supports both of them. Similarly, string varchar and char, their behavior is very similar, but it supports all of them. So that it is very easy to port a query onto Hive very easily. Okay. Those were the simple data types. There are complex data types such as arrays. Arrays are an array of values, and those values can be of various kinds of data type. So you can say that my particular field is an array of a string, array of float, or array of maps. Okay. Now the complex data type other than array is map. Map is key value pair, again a collection of key value pair. The key has to be primitive data type, it could be integer or string, while value could be any data type, whether primitive or advanced. Then there is something called structs, which is similar to your class and objects, where there are predefined keys of the data. Okay. So the difference between struct and a map is, in map any key can be accepted, while in case of a struct we define the keys which are only possible. Then we have union data type. This is something new to lots of people. A union data type essentially is a single data type containing multiple values, and only one of those multiple values will be used at a time. Okay. It's like one top of another. I'll tell you why. So for example, authentication could be integer, string, or something else, but it will be only one value at a time. So authentication on your website could be from Google, or from using email ID, or using Facebook ID. And when it's using email ID, it will be string. Okay. If you're using ID from Google, it might be a number, and so on. So essentially, ist- uh, union makes it possible to have multiple kind of data types in a single field. Okay. Union makes it possible to have multiple kinds of data types for a single field. Okay. It can be string, it can be integer, or it can be something else, but it will be only one thing at a time in a row. So these were the data types. All right. So any questions still here right now, or everybody has gone to sleep? Oh, Sweta is awake, and Abhishek also seems to be awake. Okay. Okay. Yeah. All right. Yeah, Nitika is asleep. Otherwise, there could have been lots of questions. Oh no. Okay. All right. Then it's too late for people from India, so I cannot blame them, and I can also blame my monologue. All right. So great. So see you tomorrow, and till then, go through all the exercises and finish. And I'm yet to finish the reviewing of everybody's exercise. I've reviewed some of the exercises. Some of the exercises are still pending. All right. So all of you, please finish your exercises online, and then we can have discussion tomorrow. Great. All right. So all right then. Bye bye. Have a good day tomorrow, and we'll have a discussion tomorrow again. Bye Abhishek. Bye Pop. Also, yeah. Bye Amar. Bye Nitika. Bye Shweta. Bye Vikas. Bye Minu. Bye Sanjay. Okay, so people were awake actually. All right. Bye bye. Have a good day.